Good morning. Happy Bowtie Friday. Today we're going to do a speed run through part one of the scaffold-eth curriculum, which is this part one is just an introduction. Let's just jam through it. I'm just going to do a speed run. The best way to do this is to go through it by yourself and then hit me back with feedback, but I'm going to do a speed run just to kind of cover what you end up building. So you'll need Node.js, you'll need Yarn, you'll need Git. Get those installed. Then you clone down the scaffold-eth repo. Then you check out a specific part one branch that has everything ready to go. It's just a few small tweaks, like the to-do list is updated in scaffold-eth to get you ready to go. And then you do a Yarn install. I'm going to glaze over a lot of stuff here. We're not going to worry about it. This is more of just a speed run to get to the other end of it. It's going to take a while too. But let's pull up a code browser and look at what packages we have. So while it's installing, we've got three packages. You've got your React app and the source code, and then you've also got Bidler, which is where your contracts are. So this is kind of your back end, and this is kind of your front end. We'll pull up Bidler contracts. Let's bring our smart contract up and make sure we have it located and we know where it is. Let's also bring up our smart contract wallet.js. So this is our front end. So basically, you can think of this as here's your back end, here's your front end, and then once everything gets installed, you can do a Yarn start, and your app will come up eventually. That takes some time. And if we follow along with the instructions, we also need to do a Yarn run chain. That brings up our Bidler blockchain with some accounts that are loaded up with test ether. And then we need to do a Yarn run deploy. Yarn run deploy is going to compile our contract. It's going to deploy it to our local chain, and then it's going to take the artifacts and it's going to plug those artifacts into the front end. So we should have a whole dev loop here, right? Where we can tweak our backend contract, deploy it all, and then tweak our front end buttons, and the buttons should be hitting stuff on the contract, and it should be a very tight iteration loop in terms of Web3 prototyping and building an application on Ethereum. Here we go. We should have a web browser up. This is what your local host looks like when it comes up. Great big to-do list, but we have a smart contract here. And what I always like to do, see this deployed to 7C, 2C, I always like to do one more Yarn run deploy just to see the full loop happen. We should see the contract gets deployed there. We even have some console logs there. Now, if we're watching over here, we should see our new contract show up, and it's 8858, and you can see it's 8858 here. Okay, cool. I feel like we're grounded, right? Everything is here. We've got a nice little structure to work with. We need to. So this is out of order. I can already see this. We need to, let's follow the guide. Let's follow the guide. What's next? Okay, so I talk about providers, I talk about hooks, I talk about components. But the first thing you do is you grab a read function. And this is kind of a not very necessary function, but to introduce to the reader the difference between a write to the blockchain and a read from the blockchain, I wanted to have these two different functions. So we see that we're tracking an owner, right? And the owner can withdraw, and the owner is set in the constructor. Now, with this read function, it's a view function, we can see if the owner is some address, right? We can pass an address in and it'll tell us if it's the owner. That's a read. And then a write would be update owner. So whoever is the current owner should be able to update the owner. Now look at this. We can just do yarn run deploy. And if you wanted to iterate on just the Solidity for a little bit, if I could spell compile, you could just sit here and do a yarn run compile and kind of poke around at it and get it just right. But then once you're ready to go back over to the other side, you can deploy, right? You can even do yarn run watch, and it will watch for your contracts to change and just try to do that hot. But I kind of like the visceral experience of deploying my own contracts, I guess. I don't know. Okay, here we go. So we updated the owner, we deployed it, and now we should be able to see in our app what happens. What we are the yeah, so we have functions, but we're still not the owner, right? So the owner is still this guy. So where is that coming from? And it'll say in the article that we need to go edit this args file. So right now we're running on this kind of automatic deployer. Eventually you'll have a custom deployer, but this auto deploy just goes and looks for args, and there are the args. So let's grab our account here, this little brown mustachy guy, and let's paste him in here and hit save and do another yarn run deploy. And this time it's going to deploy the contract. What's our name? A0. I bet A0 is going to be the owner of the contract, and we'll be able to see it over here. Bickety, 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 bam. All right, so now we are the owner, and we can set who the owner is, right? But right now we can't do that in the front end. So let's move over to the front end. I bet it has some nice stuff that we can copy and paste. Oh, nope. It's not front end time yet. It's deposit time. And it tells you that you should deposit. So let's grab some funds from the faucet, paste them in, and try to deposit. Transaction reverted without reason. Well, the reason is that the contract cannot accept funds. We need a fallback function. So let's throw a fallback function in there. Cool, save, yarn run deploy. Now we should be able to deposit funds into our contract. Isn't that a nice tight iteration loop, right? I mean, it's just like, oh, fallback function. Boom, contract gets a fallback function. Boom, deploy it. Boom, I'm over in the front end and I'm testing it in my app. And now, look at that, I can deposit funds into my contract. Pretty rad, pretty rad. But I think it is going to tell us, yeah. So this is programmable money, right? We need to, let's put some logic in here and say that you can only deposit funds, and warning, there are ways to still put funds into this thing, but technically, for the purpose of this experiment here, we can set a limit, and we can check that the balance is less than or equal to that limit, and then throw an error if not. So basically we just put a limit into our wallet to make sure no jabronis go throwing a million into our unaudited contract. Cool, and now it goes. Let's see what the front end. Okay, nothing's gonna happen in the front end yet, but now we have all the abilities we need, right? We are the owner. We can change the owner. We can deposit into it, and it's limited, so it's safe. Okay, here we go. All right, run. We deployed. Okay, now. Oh wait. Can we see it over here? Yeah. Let's change the owner. Let's copy this. Let's deposit some funds in there first. Did we deposit funds? Yeah, okay. Then let's change the owner to this guy, and boom, look at that. So now the contract owns itself, essentially locking that 20 cents on this fake testnet forever. Okay, cool. We are good to go. Let's move on. What is next? We need to keep track of friends, right? Now that we have the wallet and it works great for us, now we need to talk about social recovery. If I lose this key, it's gone forever. Or if I happen to put the owner of the wallet to the wallet itself, it's gone forever, right? What would be nice is if we had some kind of soft Web 2-like feeling that maybe this could be recovered if I'm a total knucklehead, because I am. So let's grab friends and let's paste them into our contract. What we're gonna do is we're gonna keep track of a list of friends' addresses and set a bool to true for those addresses. And then we're going to set up a function that allows those friends, or allows us to update the friends. So basically we've got a friends mapping, and then we have the ability as the owner to flip a bit for a specific friend. Set a friend to true, right? And then we can always check that by just checking the automatic getter that's created for that friends. And yarn run deploy. Let's head back to the front end. So in the front end, it says we want to track our state of our friends. Let's see, bickety bam, boom. So friend address, set friend address, and I think the next thing it has us add, okay, then we need a function to update friend. Look at that. It's so interesting, the symmetry we're seeing here, right? So we created a friend mapping over in our contract, and then we built a function to update the friend in our contract. Then we moved over to our front end and we created this state where we're tracking some friend's address, and then we have this update friend's address. And then we can go in and set up the display for the owner so he can paste in a friend. Let's see, let's put that in there. And then I think we need to drop this owner display in somewhere about right there. And now in our front end, our owner should be able to add friends, okay? So now let's grab localhost 3000. So I'm bringing up an incognito window or just some other window, and I can give this guy some test ether if he wants to play around. We should see his balance update. He can't deposit, like he doesn't even see the deposit withdraw buttons because we're hiding those. Technically he could deposit, but we're hiding those from him. And he can't see the friend stuff. So basically he just sees this. He doesn't really see a whole lot of anything. But what I can do is I could copy his address and I could come over here and say, well, yeah, I mean, that dude's my friend. Or I could do like maybe AustinGriffith.eth is my friend. Yeah. So we're setting friends in the wallet. We're keeping track of them. But we can't really see what's going on. It's hard to, I'm just kind of hitting save and it's just kind of disappearing into the ether, right? There's no database here. We're talking to the blockchain directly, and it's not really telling us a whole lot about how our friends, because we chose not to have an iterated array that we could look through and know who all of our friends are. We basically just have a mapping. So we have to have an address of a friend to check to see if they're our friend anyways. So what we need to do is some kind of off-chain way of keeping track of what friends have been added and removed, and that's where events come in. So we can, and events are, admittedly a little clunky in ETH1, but they are still handy for this front end, this off-chain stuff, and that's what an event is for. Like a contract can't read an event. Events are like a relatively cheap storage method on chain that allows you to put stuff on chain that can be read off chain, but contracts can't read it. But what we're going to do is anytime we update a friend, we're just going to trigger one of these events. And then let's put that other line in there to emit that. Uh-oh, I've lost my, here we go. Lost my marbles, y'all. All right, here we go. Grab the emit friend and throw that into our contract. Okay, so anytime we update the friend, we're going to trigger this update friend event, which can be read by our front end. Let's deploy that. Okay, then in our front end, and it's telling us, ooh, watch out, this line is already there. So don't copy and paste that line because it's already in our front end, because I snuck it in there so I could make the to-do list show whether or not we've done this stuff yet. So we're already listening to our friend updates. And now what we need to do, actually probably just by doing that, it's going to get checked off. Nope, we need a list, and we'll need to add a friend. That's what we'll do. Okay, so down here, where do we want to put this list? Right here, I bet. And this list is just going to take those events that are triggered from the smart contract, display them in the front end, and if they're true, put a little green checky. If they're false, put a little red Xy, right? Very, very, very simple stuff, but very valuable feedback in the front end. So now, let's see, we're pasted in. What happens now when I add this guy to the contract? Come on, friend updates. Yeah, look at that. It's like, oh yeah, this dude's a friend. And then what if I do AustinGriffith.argent.xyz, right? Yep. Okay, cool. That guy's a friend too. Cool. I'm just having too much fun with this now. Okay, cool. So now we can keep track of our friends. We can see our friends in the front end. What is next? We probably need to start talking about social recovery. Okay, so if I've lost my private key and I go to my friend, he needs to be able to trigger something. And that trigger needs to basically send the funds back to some kind of cold storage. But we have to assume that our friends could also be malicious. You have to always think about the adversary in smart contract programming, because you are exposed to a world of jerks at all times. We all are. So we've got a list of friends, and they can trigger this thing, but what we need is a timeout period in which I could cancel it before it gets to the moment that it destroys everything, right? So if a friend happens to want to grief me and they hit recover, I could basically cancel that, cancel them, get new friends. and my funds stay in the wallet, fine. But if I do lose my private key, I still want that friend to be able to hit recover, and I want it to wait some timeout period and then return, and then another function will call and it'll return the funds. So we're going to have to keep track of not just a recovery address. So back to our contract, we're going to keep track of not just and normally your contract is probably not structured like this, right? This is a prototype. We are going to keep track of the time to recover. And this is basically the mode. If this thing is greater than 0, it means that we are in recovery mode, and either it's going to time out and go or not. This will be the time delay. So this thing triggers, then we have this much time before all the funds will be sent to that guy. Okay? And 120 seconds, come on, ain't nobody got time for that. So I'm just gonna set it to 20 seconds. Normally you'd probably set it to a couple of days, right? Like, or a week. I don't know. Argent does this. I'm not sure. Maybe it's 24 hours. Something where like I could be off the grid and come back and see that one of my friends griefed me and cancel it before my funds go to cold storage. It's not that big of a deal because I could just redeploy, but still. We don't want our friends griefing us, and so we need some kind of period to keep that so I can cancel them and cancel the recovery. So set recovery address. So we're tracking the recovery address. Then we'll have a function for our friend to call, which will start things. Then we'll have a function for me to call, or the owner to call, that could cancel things if that's not what we want. And then finally, we'll need a recover function that actually gets called. And this is kind of cool because basically anyone can call this recover function. It's yarn, get out of there. Yarn run deploy. So this is just a public function that anyone can call, right? And what's funny about it is it does have self-destruct at the end, so it does destroy the contract. So if basically the timeout period has passed and the recover has been triggered, and so they've triggered it, it's past the timeout, it's really time to recover, we can see it just by this require, go ahead and let anybody destroy it, right? And if they do destroy it, what's interesting is they'll get a little bit of gas to execute something. So someone could technically see this, destroy our contract for us, and then use the gas to go deploy some other junk all in one transaction. So somehow they're incentivized to do that, but really it'll be us doing this destroy or this recover here. Okay, so here we go. Oh, I didn't save it. Here we go. I'm yammering on. This is a speed run. You don't yammer in a speed run. You got to get it done. All right, here we go. So we are going to now deploy our contract. I think that's the finished contract as far as we need to go. But let's start working on it in the state. This is going to be probably the most complex UX. It's going to take us a while. Where are we? About 4/5 of the way through. 4/5 of the way through the afternoon. What? Okay, here we go. Grab the recovery address and back to our front end. We will paste in the recovery address. So now we're going to track the recovery address in our state, and we're going to display to the owner the ability to set the recovery address. And then we need to track the current recovery address from the contract. Okay, so we have our own state in our browser, but then the contract has its state, and if this state changes while we're over here, we want it to like update that way, right? So we're watching the contract for the state, but we're also kind of keeping our own local state as we make changes, and then we can ship it to the contract with this function down here. But let's get to that. Okay, so we also need to bring in time to recover and the local timestamp. This is a nice little hook. Look at this. Use timestamp, pass into provider, you get the current timestamp. Okay, and this is the most tricky copy paste. It goes right in that spot where we were, just right there. And done. Okay, where are we now? Cool. Okay, so let's go play with it, see where we're at now. Are we deployed? Let's just get a fresh deployment if we aren't, just in case. And let's get this guy some funds. Boom, boom, boom. Let's make sure this guy has some funds. Boom. Okay. And let's see, let's make sure this guy is a friend. Right. He's a friend. And if we're gonna recover, let's recover to AustinGriffith.eth. There we go, we've got that saved. Basically, this is all ready to go. I could deposit some funds into my contract. We're getting real close here, folks, real close. And then this guy over here, oh, so here's where we're lacking. Everything is great here. We've got our friends, we've got our recovery mode. We even have a switch here, we don't even know about it yet, that can cancel things. But this guy has no way of doing anything, right? So we need to work on our friend display. So what we'll do is we'll track whether or not they are a friend in our state of our app by just following the friends array and passing in the address of the person that's here, right? That's using the browser. And then let's see what's next. Then we need a big else if that will go right after the owner. So there's, if you are an owner, I want you to display all of this stuff. If not, I want you to display the friend stuff. Cool. What is next? All right, that's basically it. We can play around with it now if we don't have any errors. Let's see where we are. Okay, he's a friend. Yes, okay, so this is the important stuff. Now we can see that our friend has this cool little badgy guy. Okay, and then let's kind of move that over. Let's do something like, maybe like that and this. Okay, so if this guy decides that he wants to grief me, he could say recover. And I can see right here, look, it starts the 20 seconds, but I could be like, no. And I could go cancel him. Like I could just say, whoa, this guy is a jabroni. Do not let him do that again. And when I cancel him, he's gone. Okay, but let's bring him back. That was a JK. You are my social recovery guy. I'm gonna go do a bunch of cool, crazy stuff. I'm out late one night. This is a paper wallet. The paper wallet falls off the side of a boat and sinks, and I've lost my private key. And my 60 cents, my 0.003 ETH is gone forever. Wait, I have a friend, and he can recover it. So I go and I send my friend a text, and I say, please recover, and he says, okay. And he clicks the recovery button, and the time starts. And since we're on a local chain, we can't really see the time update because there's no blocks being mined regularly. So I will just hit this. Recovery 10 seconds. Recovery 7 seconds. Recovery 3 seconds. Last chance for the owner to recover it, and he doesn't. So now we got a rocket ship. Are you ready? Get your bow ties ready. Recover. Watch that zero. Oh, look at that. The money's gone. All right, the money is gone. The contract is destroyed. How do we prove? Let's see. Let's connect to my MetaMask, and let's put my MetaMask on localhost. And look at that. There's that 0.3. There it is. There's a 60 cents recovered to my cold storage. Thank you for coming along on this journey. Build. Get some scaffold-eth in your life. Build some stuff. Check out this smart contract wallet with social recovery and send me feedback. Happy Bowtie Friday. Thanks for coming along on this journey. Peace.